So let's begin with concave lens where the object is at infinity. So we're keeping the object at infinity. So we have the object at infinity, right? So what happens to the image? So we have seen this, we have discussed this also. Light from infinity will be parallel to your principal axis. Okay, we can arrange in this way. So we know what happens to ray which are parallel. They will converge at focus. And this is basically your ray diagram. That's it. Okay. So I'm not going to show you guys how to do it on a paper. It's very simple. So once you do all of this, don't forget to name O, F1, F2. Then this is C1, C2. Now, property of the image. So the image is highly diminished. Orientation is, see, this is something which can be captured on the screen, right? Whenever you see any solid line meeting, okay, any solid rays meeting in the diagram, that is, so by default this can be captured on the screen, so it will be inverted. Since it can be captured on the screen, it is called as real image, and this is at f2. So let me show you this practically. And by the way, the object is not at infinity, so it is a bit far away. Okay, so what I'm going to show you is not actually an object at infinity, but it is significantly far away object. Okay, so please have a look at this. So we have the screen and the lens. So that is your image that is captured on the screen, right? And that is your sharp image. That's it. Okay, so the distance from the screen to the lens is your focal length. So how do you use such a scenario to find the focal length? First thing, to heat things up in solar cooking and all of that, we can make use of this, right? So if you have sun rays converging at a point, this I've shown you guys when we're talking about convex, sorry, this is not concave, this is convex. So why convex lens is called as converging lens. So you can focus the sunlight, basically used for heating purpose or generation of electricity. So concentrating your signal strength or light or any kind of, it is used for quite a few purposes, right? So anyways, main thing over here is I want you guys to understand is we can use the setup to find the focal length of a given lens, convex lens, that is. Right, other uses we'll be discussing in time. I'll be listing that. So since we are going to use this particular lens, I want to make sure that you guys know this value. So this lens is around between 13 and 14. Okay, and this object screen starts from 0 over here. So 0 to 13, 14. Approximately this is 14 centimeter. The focal length of this is 14 centimeter. Right? So this is something that you have to keep in mind, because based on this fact, we're going to make or do all the experiment. Right? So see to that you guys remember that value 14 centimeter. And this is something that again you guys need to practice. So quite simple, parallel beam of light converging at f2. And the properties of the image, same as your mirror. And practical, yeah. And the usage is focal length and pretty much all the heating purpose, like solar heater, or if you want to increase the efficiency in solar panels to concentrate your signal strength, right, to use for your telescope, right, basically microscope, quite a few things. Okay, oh yeah, no, not microscope, telescope. Microscope is a different case. I'm talking about this case. Okay, uses of this particular case, convex lens using in this particular case. How is it useful? Convex lens as a usage, there are quite a few that I'll be listing in time, but this particular case, the usage is this two. Right guys? So please pause and copy it off.